that was similar to Dr. Barron, just because like I still have a hard time, like I'm pretty sure everybody is with hypothesis tests on how to do these. So I decided not to do any sort of a graph or anything because I don't think it's necessary for this one, just because I'm looking at rather small numbers. I think it'll be pretty easy to see where the results are coming from without having a data visualization of a box chart like she had, or a box plot. So I did the same thing where I wanted to look at recent versus non-recent sales of these ski condos. And recent was defined as 2016 to 2017, and non-recent was defined as before 2016. So we looked at all of the bedroom counts, and my research question is I wanted to know if the number of bedroom counts had changed over the years for the apartments. And so in order to conduct this hypothesis test, which I figured it would be the same, so there's my null hypothesis right here. And then the obvious other hypothesis would be that it is not equal. So when we're looking at this, I know that Dr. Barron had said that there's potential that these aren't independent, they aren't completely random because it's all in the same complex. However, with bedroom count, I think it gets a little bit trickier because bedroom count, 0, studio, all the way up to 3 is, pretty typical throughout everywhere. The only difference being is that perhaps this apartment complex has, well, obviously they have a set number of 0, 1, 2, and 3 bedroom apartments. So that's kind of the interesting thing about this, is that it could not be completely random because 2 bedroom apartments and 1 bedroom apartments are probably much more popular or much more numerous than 0 or 3 bedroom apartments. Okay, so anyhow, then you want to look at, do we have a nearly normal distribution or large n's? And for this one, we do have a pretty good one. The total number for n was, what was that? 83, I believe. 74, 83, yeah. So we have pretty large n's, but when we're looking at 2 samples and breaking them apart, maybe not so much, but we're going to go ahead and keep going with the tests anyways. And then you want to look at the homogeneousness, I don't know how to say it, like whether the n's are the same or not. And in our case, obviously they're not. So we're going to go ahead. And so the first thing that we want to look at is the sample difference between the 2 means for these different groups. So for this one, we're going to take the mean number of bedrooms from the original, aka the old apartments that were sold, and then subtract the average number of bedrooms and apartments sold recently. And what we get is a difference of 0.06. And I know bedrooms are not sold in decimal points, but just for the sake of this, we're going to let it go. So 0.06 is not a big difference. So then we want to calculate our test statistic. And how we're going to take that is we are going to grab the sample difference here, and then we're going to subtract that by 0, because that's what we said our null hypothesis would be over here, that they were the same. In other words, the old mean minus the recent sold mean would be 0. So we subtract 0 here, and then we're going to divide by the standard error. So we divided by the standard error. Again, I'm not going to go through. I just copied the equations that she had done for the other, for her sheet, and I'm not going to run through those either, so I'll just black them out. But this was our calculated standard error for, excuse me, for this data set. Okay, so with that, we get 0.07, and then we're going to calculate our p-value, and our p-value is all the data from both sides. And then we want a 2-tailed test, so we have 2 here, and then we have the 3 here, which I cannot remember for the life of me what the 3 stands for, but someone can remind me. But this was the formula that we were given, and our p is 0.76. So if we go back to Let me go back to the lecture real quick. Oops. I recorded this like 3 times, so I'm all jumbled up. Okay, so I'm just going to use this as an example. So far, our t-test in our hypothesis test that we just did was 0.07. I wanted to make sure I had that right. So 0.07 is right here. Now, obviously, that is well within reasonable, and our p-value was 0.71. So therefore, if we were to look at this, we would look at all the data falling on both ends, and it would be something very high percentage-wise, saying that basically where did I go? There would be a high percentage of data that falls in those two tails for us. So then we're going to make, there we go. See, this one says 41% is under because that's from the test that she did, but ours would obviously be much larger than that because our t-test statistic was only 0.07. So I hope that helped. And then we're going to make a decision. So I set my significance threshold at 0.05, and our p-value was 0.76. So well above that, which means that we cannot reject our null hypothesis. So the decision is going to be that we would retain the null hypothesis. And then our conclusion is just going to be simply there is not enough evidence to suggest that the number of bedrooms in purchased condos have changed over the years. So pretty simple. Like I said, I really wanted to do something that followed along with what she did because I was trying to walk myself through this as I did. So if anybody has any pointers, let me know. Thanks for watching.